A line rated for 63 to 630 mm pipe can still become the wrong investment if its output, tooling, and acceptance conditions do not match the products the plant will actually sell. Diameter coverage alone says little about changeover losses, dimensional stability, scrap, or sustained production under the intended formulation. Selection should begin with a precise production definition. Specify the target diameters, wall thickness range, resin formulation, end-use market, required standards, expected operating hours, and acceptable quality variation. Identify which sizes will run routinely and which will be occasional. This product mix determines the extruder, die package, calibration components, downstream handling, spare parts, and changeover strategy. Water supply and drainage pipes also require separate consideration. Water supply applications may emphasize drinking water requirements, pressure performance, traceability, and project owner documentation. Drainage applications may place greater weight on geometry, joint compatibility, chemical exposure, installation conditions, and non-pressure requirements. Suitability must be demonstrated for the intended market and use, not inferred from a broad product label. Every requirement should become measurable. Nominal diameter must be translated into permitted dimensional variation. Capacity should mean stable, saleable output under a stated formulation, rather than a short laboratory maximum. Quality needs an inspection plan defining measurements, sampling frequency, test equipment, and escalation rules. These details prevent disputes between a supplier demonstrating a peak result and a buyer expecting repeatable plant performance. A disciplined comparison examines 6 factors: pipe range, application boundary, saleable output, dimensional evidence, tooling fit, and factory acceptance and service support. Product and application fit should be resolved before price comparisons begin. Output and dimensional records then show whether performance can be observed and repeated. Tooling, training, spares, and response responsibilities determine whether that capability can be transferred into reliable operation. Wall thickness deserves particular attention because it affects material demand, cooling behavior, line speed, setup sensitivity, and stabilization after a change. Any capacity claim should identify the pipe geometry and wall thickness conditions behind it. Without those conditions, competing output figures are not comparable. The equipment proposal should also explain how resin behavior, screw design, die design, temperature control, sizing, haul-off conditions, and inspection work together. Claims about specialized screws or molds are useful only when linked to testable outcomes such as even plasticization, dimensional consistency, surface quality, stable operation, and controlled scrap. Strong evidence includes the reference formulation, pipe dimensions, run duration, average output, inspection readings, stoppages, and rejected material treatment. One good sample cannot replace a documented stable run. Maximum output must therefore be converted into accepted production capacity. Separate nameplate capacity, trial capacity, planned capacity, and accepted output with a calculation basis for each. Record startup scrap, trim, rejected pipe, quality holds, speed changes, and interruptions. A useful operating record also captures what happens when the line starts, pauses, adjusts, and returns to normal speed. The factory acceptance test is where commercial promises become observable behavior. Before shipment, agree on the test material, die and settings, pipe size, wall thickness, trial duration, inspection frequency, acceptance criteria, allowable interventions, deviation handling, and ownership of the records. Retain dimensional results, surface observations, alarm and stoppage logs, scrap disposition, operator actions, interlock checks, and recovery steps. If the intended formulation or product size is not tested, record that limitation explicitly. Finally, align technical scope with commercial scope. Define responsibility for trial material, utilities, foundations, electrical interfaces, installation labor, commissioning, training, first-year spares, performance verification, and unresolved deviations. The defensible purchase is not the line with the widest stated range or highest peak output. It is the configuration proven against the actual order mix, documented operating conditions, measurable acceptance criteria, and a complete handover plan.